Hello everyone, in this video we're going to look at the homework 4, topic 4 homework. Okay, so make it bigger. The first question, determine whether the scat diagram indicates the linear relation. So you can see these dots here are not linear relation. Here is linear but jump down here, so it's not linear relation. So the data points do not have a linear relationship because they do not line mainly a straight line. It's not a straight line here. So it's this one. Continue the next one. There's not linear, so that's it. Okay, second one is pretty much similar to the previous one. It's a linear relationship. It's a positive association. It's positive. It has a positive slope, so it's positive linear relationship. And next one, you can tell this scat and 0.52 not really a good linear relationship. So all of the three pictures, this is not very good linear relationship. So number 2, graph 2 is the bad one. And r equals 1 is very nice one. All the three pictures here, number 3 is the best picture, have a linear relationship. So C would be this is number 3. And R 9.9 is number 1. Okay, so next question. Shoe size and IQ not correlate, no relationship, not correlated. Next one, and the commute time in minutes and a well-being score. So what you can do, you can open this, just click here, open the StatCrunch, and then you have data here, right? And according to common sense, we can tell that the explanatory variable, which is x, okay, x determines y value. So the well-being score will depend on the commute time, which means a commute time will affect the well-being score. So explanatory variable is commute time, which is the x value, and the y value is good corresponding well-being score. Okay, so it's C. So how do you graph this? How do you graph this? What you can do, you open the StatCrunch graph. You can see the graph here, and then you have C scat plot, and choose x as commute time, choose y as choose x as commute time, y is the well-being score, and you compute. You have the picture like this. Then you compare this one with all of this what is this? Compare this picture with the A, B, C, D. Only A is the best picture. Okay, so that's for this one. Number 6. Number 6 is very similar. Graph the picture, you have no problem. So how do I find the R? I think this R, you have to find the R here. Okay, you can see the picture is a negative linear relationship. How do you find the R here? You can also do with a StatCrunch, open this stat and summary stats, and then go to correlation. Press it, press Control, select the other one, and compute. You're going to see the number. This is the correlation coefficient R. So it's negative 0.973, and it rounded up to 4. And it appears to be negative linear relationship. It's negative slope, so negative linear relationship because R is negative and less than the negative critical value. Okay. So number 7 is pretty much very similar. So it's not really similar. It's another one. But the predicted grid point, so 8 hours, which means x equals 8. What is y value? You just need to plug in x into the equation. So it's 0.0556 multiplied by 8 equals negative plus 2.9176 equals. So this is going to be the y value. So copy that and paste it here. Basically plug 8 into x and solve for y, and y equals this. Plug 8, x equals 8. Plug into here, find the value is 2.47, and that's right. Okay, so for each additional hour that students spend time playing video games in a week, the grade points average will decrease for sure, right? The more video games you play, your points will be lower. So by 0.0556 points on average. So which means you don't need to, please don't play more. If you want an A, play less video games, right? All right. If appropriate, interpret the y-intercept. Y-intercept means the student never play video games. So if the student don't play video game, that's the score. So the grade point average of a student who does not play video game. The y-intercept means x equals 0. X equals 0, they play 0 video games. So that's it. If a student who plays video games 7 hours, you got 2.64. Is the student grade point average above or below among the students who play 7 hours per week? If you has 2.64, okay. The average is 0.0556 negative times 7 plus 2.9176 equals. Basically, you plug 7 into the equation. Find out the y value is 2.56. Well, 2.64 is above this average, so it's above. Okay, you plug 7 into the equation, compare this value with this value, and this is above the average. Above this 7 average value is this one, right? All right, next one. I have the data. So linear regression line, you can do that. Open the StatCrunch, and you can do linear regression. So regression, simple linear function. X variable is height, and the y variable is the head. Circumference is y. So now compute. You can tell the least square function is y equals what? Okay, I'm going to do it one more time and so you can see it again. Regression, simple linear. X choose x, y choose y, and compute. And have the data here. So how do you interpret the data? Intercept is mx plus b. Intercept is b. So 4 decimals is here. Put it here. It's 50. Slope is mx. Slope is 0.1740. So this is slope. 4 decimals. Okay. So this is, you can compare this. This is mx plus b. Intercept is b. This is your slope. Interpret slope. It means if the height increased by 1 inch, that what is x, what is y? Let me check, double check. X is the height. Okay, so the head circumference will increase by 0.174. Okay, so interpret the y-intercept. Y-intercept is x equals 0. So the height equals 0. It's not appropriate to interpret it outside of square model. If the height increased by 1 inch, head circumference increased by this on average. The y-intercept, okay, the y-intercept is the child head circumference when the child's head height is 0 inch. So that's how you interpret, but you don't have a height is 0 inch, right? So it should not be, this one should be out of the model. Okay, you don't have a height that the baby should be like more than 0 inches. Use a regression model to predict the head circumference of a child who is 25 inches tall. So it's 25 inches tall, plug 25 into the model. So 0.174 times 25 plus 12.7150, 17.0 plus Control C, Control V. Okay. And compute the residue based on the observed, that is the head circumference which is above or below. The residue based on the circumference is, okay, 17. Compute the residue based on the observed head circumference of 25 inches. Is the head circumference of the child above average or below average? Residue. Let me see. Where's the residue? The residue based on the observed circumference 25 inches. Oh, so we have observed value. 25 is 16.9. 16.9, okay, so minus 16.9 equals 0.165, 0.17 rounded. Y minus y hat. So y, okay, the negative. Okay, so because it's 17, y is this is observed value minus this value. Okay, so 25 you got 16.9, subtract 17.065. That's the difference of the observed value and the average value. The model value is this one. So y minus y hat is this number. You got negative 0.17. So which graph is right one? Basically, you just use you can add it. For example, you can add it. You can graph it. Graph it with what? Just 50 line. Graph with the mean interval. Either one is okay. You can just graph it. Compute it. Next, that's a graph, right? So this one is the green, is the interval. You don't look at the green one. Look at the red one. Maybe I should just not choose that with something. Just a 50 line. Right, just 50 line have this. Compare this one with the ABC. I think this one looks pretty like this. So it's A. I think not this one, not this one. This one is very similar as our picture. Compare this picture with this picture. This is pretty much the same. Final check. Okay. So that's number 8. More. Is the head circumference of the child above average or below average? Let me see. We're looking for this one. The below average is this one. Okay, so it's the picture says the picture is average is this, so it's below average. Okay, if you look at the picture, this is the number here, value here, so it's the average is this line, so it's below the average. Okay, so you can finish the rest of them. Should be pretty similar. Okay, and next one, number 9. You find the model. So what do? You can do open the StatCrunch. Stat, linear regression, simple linear regression. X should be the weight. Y should be the mileage per gallon. Because it's heavier, the less mileage per gallon you have. So, and compute. The slope is this. How many decimals? 5 decimals. 0, 0. Okay. Run to constant for the slope for the intercept. So it's 41. Wait, let me double check. Oh, run the constant to 2 decimal places as I needed. So I have to do this. 2 decimals. Okay. Interpret the slope and the y-intercept. And weakness Caldwell gap per gallon, average per gallon, and it's not probably the interpret slope. Interpret slope and a y-intercept, choose the correct answer on the phone. Okay. So for every pound added the weight, you can choose this one. For every pound added on the weight of the car, gas mileage in city will decrease by this number. Okay, 0.00653 per gallon. Average is not appropriate to interpret the y-intercept because the car can't be a zero weight, right? A car has to have some weight. It can't have a zero weight car. So this is just have slope. The intercept does not explain anything for that. So a certain gas powered car weight 3,600 pounds and get 20 miles per gallon. Is this miles per gallon above or below the average? So basically plug 3,300 into the model. 0.00653 multiplied by 3600 equals, by its negative, plus 41.3 equals. So this is the average. This is the average. And now your value is 20. 20 is above this average. So it's above. Okay. So what would reasonably use a least square to predict mileage per gallon and why or not? Okay. So you look at this one and finish the rest of them by yourself. It should not be a big problem. It's going to be interpretation. Use your common sense. You should be able to finish that. And the next one, I need to explain this one a little bit. So 91.8% of the variation. So it's right here. So it's pretty simple. The coefficient is 91.8%. This result means 91.8% of the variation is explained by the least square regression equation. Next one, I want to introduce how to find the R square. So how to find the R square? You can open this one in the StatCrunch. So first you need to find the correlation. You go stat, summary stats, correlation. Correlation gives you R, coefficient. Okay, so this is the coefficient, it's R. You copy that number and square this. So copy and paste. Control C, Control V, paste in the calculator. Then you square this number because it's R squared. This is R. So square this is 0.903. So it's 90. Because it's a percentage, so you multiply by 100. Percentage, right? It's 90.31. So paste copy and paste here. 1 decimal, so it's 90.3. Okay. So continue. And R square is linear models be appropriate. First is it will be appropriate because of 90.3%. So 80 is appropriate. Okay, the R square of the variation explained by least square. R square of the variation of the Haskell is not. It is explained. Okay. Next question. So this one give you R is this number -0.964. If you have negative, you square this, it's positive. So 0.929 is going to be your R square. And multiply by 100 give you a percentage, right? Multiply by 100 give you a percentage. You have this number here. So this is gas mileage, which is Y value. It's explained by the linear model. Okay. So number 13, and you have to find R square. How to find R square? You can open this in the StatCrunch, and you find the correlation, X and Y, and this is your number, your R. And then what do? You square this number, multiply by 100 is your percentage. Okay, square the correlation, multiply by 100 is percentage. So you got a percentage, this 86%. So how do you get it? The difference of that? It says the problem says how does the addition of the 12th car, which means what if I get rid of the 12th car? Basically means now I can calculate 11, so don't take that 11. Sorry, don't include that 12th car. So only use 11. What about that coefficient? Now let's do it. If I do 11 car, so correlation x and y, compute this number. Its number square give you r square. So you copy, control, and square this number, which is 88%. Multiply by 100. Okay. The additional one is 86. So from 88 to 86, actually reduced. Right? So if you don't have the 12th car, it's 88. Now you add 12th car is 86. So it's from 88 to 86, you reduced by 2.3. So minus 86, you got 2.3. Okay, so that's how I do this. This is out of the topic 4. I think I almost explained 100 of the problems. So if you have questions, just let me know on the topic 4. Okay.